Yes, ma'am.
Yes, ma'am.
Okay. Okay. Uh, okay. Good afternoon, everyone. We have 22 students logged in, so let's begin our session. Fine. We have already completed the introduction chapter, that is chapter 1 and chapter 2, where you had the introduction for OOP, that is a concept of object-oriented programming. And you have already seen the difference between three programming languages. I mean, the programming techniques, right? Unstructured, procedure-oriented, and object-oriented are the three important programming techniques. And in this particular module, we will be dealing with the concept of object-oriented programming. Okay. So in order to go in depth with the concept of object-oriented programming, we have the very important concept, that is objects. Okay, as the name says, it is object-oriented programming. So every programming the thing or the module or the concept you have here, it revolves around the concept of object. Okay. So we know that object-oriented programming is one of the programming techniques majorly used everywhere. Okay, and here what is important is objects and classes. Okay, you create a class and instance of the class is called as an object, and you can have any number of objects created. Okay, any number of objects could be created in a program. Fine. So in general, objects are considered to be the independent pieces of code. Okay, and when you have more than one object in your program, you can establish some sort of communication between them. Okay, that is been called as message passing technique, so that the objects can communicate, they can share the data, they can share the methods, and so on. Okay. uh, Data structures are combined with related functions to create reusable objects. In the sense, see, I have a car, okay, model, some car is a object. Okay, so when I say car is object, car has some data, and when some operations are performed on the what I say object, okay, there is, then we can reuse it for some other purpose. In the sense, say I have something called as current speed, right? And you change the speed of the car using maybe changing of gears. Okay, so I can say the the current speed or the speed of the car as one data which is related to the object car, and it can be changed by invoking a function called change gear. I can change the gear to 1, 2, 3, and 4, and accordingly it is the changing of the speed of the car, right? So there will be some data, fine, and those data has will be used by something called as functions or something called as methods. Okay, or so these two together form objects. Okay, and objects are reusable. So the examples of object-oriented languages are C++, Java, C#, Smalltalk, etc. Fine. To be very specific, object is something which you can see, which you can touch. Okay, it's something like a material. Okay, you can see the object, you can touch the object. That's what I gave you example of car, right? It's an object which you can see. It's a physically existing object. Okay, so that is something which I can say, anything which you can physically see. Then in the software, what do you mean by object? Okay, in the software world, what do you mean by an object? It is a collection of related variables and functions. Okay, it is a collection of variables and functions. You will have variables are nothing but some data, right? Something you store in a computer memory is called as a variable. And to have the appropriate use of those variables, you should have something functioning in your program. Only then the variables can be used, the data can be used. That means it should be used for some purpose. Okay, so that is called as the functions, or in OOP we call them as methods. Okay, so An object is a collection of related variables and functions, and generally these software objects are often used to model real world objects. Okay, that is what the statement you can see. Okay, they are modeled after real world objects, they are mapped to real world objects. So the examples of objects: car, bicycle, animal, etc. Okay, there are two important characteristics of objects. It could be a real world object, what is like car, animal, etc., or a software object, any object you consider. Fine. They will have two important characteristics. One is called as the state, other one is called the behavior. Okay. State is nothing but a condition of the item. Okay, condition of the item in the sense, if I consider the what engine of the car, okay, as one object, then either the engine is working or the engine is not working, right? Either it is in the working state or it is in the not working state. Okay, similarly the switch, okay, electronic or electrical switch, it is either on or off. These are the two states. Okay, so that is the current condition of an item is called as the state. Fine. Another example is given here. When a key is pressed on the keyboard, some character is generated, and the character you generate is based on whether your caps lock key in the keyboard is active or not. If it is active, then letters you type will be in the caps lock, right? So that caps lock, when it is on, we call it as caps locked state, right? Or what is it? Are you guys listening? Or I am just talking and what is it? Guys, are you listening to the class?
Yes, ma'am, we are listening.
Okay. There is one student at least listening and responding, right?
Yes, ma'am.
Okay, Abhishek. So the key or the caps lock key will be in the active or inactive state, or caps locked or caps unlocked state. Okay. So the second important property or the characteristic of an object is called as the behavior. Okay, behavior is some operation you perform on the object. Okay, some operation you perform on the object so that its state changes. Okay, so that is why it is the observable effect of an operation or event, including its behavior. That is, pressing any key is a behavior. Okay, pressing any key is the behavior which changes the state of that particular key. Okay, so that is a behavior. You have so many other examples here. You can see one is the car. Okay, what are its states and what are its possible behaviors? Fine. You have number of gears, number of doors in the car, current speed of the car, current gear, seating capacity. These are all considered to be the state of car. Okay, current speed, it depends on changing the gear, right? And the current gear, which gear you are using, accelerate. All these are the methods. Okay, which change the state. Fine, which change the state. So similarly, there is a dog, okay, which is an object, and the possible states could be its color, its breed, its activity, and its tail activity, and so on. And these states could be changed by performing the following operations like barking, eating, wag tail, etc. Okay, these are all some of the methods using which the state of the dog could be changed. Fine. Now you can see a diagram, okay, which is actually how the object will be. Okay. When you consider a software object, as I said, it's a combination or it's a bundle of.
I'm sorry to interrupt you. Ma'am, are you changing slides?
Yes, I am. What happened? It's not visible?
No, ma'am,
we
it's not.
can only see the introduction to object-oriented concept. From that time, we are only seeing that.
Okay. I am actually changing the slides. I will stop sharing and share it again. Okay.
Sure.
Is it visible now? Screen is visible to you.
Yes, ma'am. Yes, ma'am. Now it's visible.
You can see a diagram, right?
Yeah, behavior.
Now is it moving?
Yes, ma'am. It's moving.
All right, all right, all right. So you can see in this diagram, which is it is actually a pictorial representation of an object. Okay, and object will have the variables and the methods, right? Where these variables are nothing but the states, and the methods are nothing but the behaviors. Okay, you can easily map. In the beginning, I told you a software or a software object is a collection of variables and their related methods or functions. Variables are nothing but the states and the methods are nothing but the behaviors. Okay, fine. Now you can see in the diagram the center of the object is nothing but the states or the variables, right? The variables form the center of the object or the nucleus of this particular object, fine. And the methods like accelerate, brake, change gear, these methods surround the variables. The purpose is this much, the purpose is this key. The methods try to protect the objects being shared with the external world. Okay, they hide the variables from other objects in the program, fine. So these methods are the reasons for changing the state of these variables, and the variables are surrounded by the methods so as to hide these variables, hide these data to be shared with the other objects. Okay, so the behavior, okay, like accelerate, change gear, brake, whatever the outer circle you have, they are the behaviors or the functions used in the program. Okay, they form the interface to the external world. They will have certain communications with the external world or any other objects. Okay, it is not the state or it is not the variable that are directly communicating with other objects. Instead, it is the behavior of the object which is responsible for establishing any communication to the external world. Okay, of course it is like invoking the function. Okay, through invoking the function of other object, they will have some communication and etc. Fine. And the state is internal to the object. It is private to an object. That is why it should not be shared with the external world or with the other objects. That is why they are in the center. Fine. Okay. And what is the benefit of this type of programming? Fine. What is the benefit? Using the object-oriented programming method, the first and the foremost benefit is modularity. Okay, I can create any number of objects in my program, and these objects are independent of other objects. Okay, and I can reuse the object. I can reuse the object, which is a major advantage, that is modularity. Okay, I can just pass this object to different modules of the program. That is how I can reuse it. The other important benefit is information hiding. Okay, information hiding is something like there will be multiple objects. There could be multiple objects created for the program. Okay, and what data you share among these objects depends on the access specifier of an object. See, an object can keep the data private to itself. It can keep the data private to itself. Those data will be made as private, okay, which is called as access specifier. Okay, you will study about it later. And these private data, whatever it has with it, an object has with it, it can change the type of it. It can change the access specifier of it anytime to share it with the other objects. Okay, without affecting any other objects. Without affecting any other object. I have some data with me. Initially, I think it is private to myself. But after some days, if I want to share it with some other object, I can easily share it by changing the access specifier. It doesn't affect the object at all. Okay, that is a way you have in OOP, that is called as information hiding. Okay, these two are very important methods, very important benefits of programming or object-oriented programming. You can see an example here. You are driving a car. You know that you are supposed to have an engine for the car to work. but you do not have to understand how exactly the engine works for you to drive the car, right? You just want to know that, yes, I should have an engine in working condition. But how is it working internally is none of our business, right? Yeah, that is what is called as information hiding. Exact working of the engine, we will not get. We will, in fact, we do not want to know to drive a car. Okay. So that is hidden inside that particular object, okay, called engine. Fine. Similarly, the gearbox mechanism, we just want to know its state. Okay, is it in working condition or is it in not working condition? If it is in working condition, what method I should apply to drive the car? I should change the gear, I should accelerate, I should apply brake. All these things are the methods I call for my car to move. Okay, but how the gearbox works, how the engine works is not required for me. Okay, so that is the concept of object-oriented programming or information hiding. There are three important characteristics you should learn in your syllabus here. Basically, the entire curriculum is around these topics only. Okay, so important characteristics of objects are abstraction, encapsulation, and message passing. Okay, you have few more you will be studying like inheritance, polymorphism, etc. These are the basic ones, right? Then what do you mean by abstraction? Fine. See, you know the meaning of word abstraction, right? So it is just to see, when I say object-oriented programming, in the initial class only I said it is basically used to design the complex system, right? Just to simplify the understanding of such a complex system, concept of abstraction is being used. Okay, and the purpose of abstraction is to hide the information that is not relevant to us and to simplify it by comparing it to something similar in the real world. Okay, that is what is given in the example. Also, you can see one doesn't have to understand how the engine works to drive a car, right? Yeah, we have a car and its engine is the most complex machine, I can say, right, with lot of moving parts internally. But final usage of this engine is not how this engine works internally for us, right, but what it gives out externally, right? For us to drive a car or to use that engine, it basically doesn't depend on the working of the engine. Instead, how it works, what it gives out to us externally, right? Or if I have to be very simple, you know that a working engine or the running engine can cause the rotation of the wheels, right? Yeah. Similarly, the speed of engine can be controlled by maybe the fuel you supply, the brake you apply, accelerate, all these things, but not the internal working. Okay, not the internal working. That is the abstraction. Internal working of the engine is hidden from the person who is driving the car, right? So if I consider person who is driving the car as an object and engine as another object, engine has the private data, which is its internal parts or the internal working, and that is not given to the person who is driving the car. Okay, so it just simplifies the working of the engine by saying that if you supply fuel, your engine goes in this particular speed, right? If you apply this gear, this is the speed that is reached, etc. This is what is given to us when we use a car, but how it internally works is hidden or it is kept in that particular object itself, but it simplifies the usage, right, or the understanding of that engine. Fine, that is called as abstraction. Fine. You have another better example for you to understand here. Fine. The CPU of a computer. Okay, you have a CPU, that is central processing unit of a computer. When you are using a computer, I know majority of you are not bothered how the motherboard is designed internally, right? How a CPU is designed internally or how a computer chip is made, right? What we think is nothing but the abstracted or the abstraction of the CPU design, fine? We just think in this particular process, what is shown in the picture here, correct? What we think is initially you can see the first column elements, or the first value here is basic electronic components. We know that for the design of CPU, we use the electronic components such as resistors, capacitors, transistors, etc. Right, which are used in the design of any electronic devices, right, which are the building blocks of, I can say, any other electronic system. Yeah, these are the basic the components are used. And using these basic components, what happens? There are some logic gates designed. That is a second level of abstraction, which you can see here, right? So the other level of abstraction is the Boolean logic gates are designed using these electronic components. How are they designed? We do not know. Okay, we just think that yes, there are some gates, there are some buffers designed with the help of these electronic components. Okay, that is another level of abstraction. Now, what is the purpose of these gates now? Okay, they are used in the design of digital circuits like binary counter, registers, etc. These are designed with the help of logic gates, another level of abstraction. We do not know how these gates are used in the design of most complex digital circuits, right? Because when I say a digital circuit, one digital circuit can use hundreds of Boolean gates. Okay, and that is why we don't try to learn it. Okay, that is, again, we call it as abstraction. We know what is the usage of that digital circuit, but how is it designed internally, we do not know. Okay, so you have a binary counter, right, which counts the binary numbers, or maybe in the design of a register which stores the binary numbers. Okay, so these logic gates will be used in the design of such digital circuits. Fine. And finally, these digital circuits combined will form something called as CPU. Okay, but when we see the CPU, yes, it's a motherboard. There are some gates connected, there are some electronic components used, and there are some circuits used, which gives us a CPU. That is what we know. But internally, there will be a lot of connections in it, which we are not bothered about. Okay, this is a better example for you to understand what do you mean by abstraction. Okay, so this is just one example. Similar to this, there are a lot of other complex problems in the software which can be simplified to an easy, or I can say a manageable scale by using abstraction. Fine. Next property of an object is called as encapsulation. Okay, encapsulation in the sense you are keeping the information inside the capsule. Okay, in a capsule. That means localization of information within an object. Okay, that is why the meaning encapsulation means it is in a capsule. So objects encapsulate data and implementation details. Fine. When I say an object will have two important things. One is the data, other one is the function. Okay, so how these functions are implemented, or why these functions are implemented, they basically operate on that data, right? But this data and the implementation details are hidden inside the object. You are encapsulating it inside the object. Fine. That is why the name encapsulation. It is again another method of hiding the data. Okay. So when we see an object for the outsiders or to the outside world, object is just a black box which does some behavior. Because when we see a car, it is like you are driving, you are changing the gears, something like that, right? You close the door, you apply the indicator. All these things are what we see. It is just a black box which exhibits certain behavior, correct? So the behavior of any object is changed with the help of methods that we already discussed, right? We change the behavior of an object by using methods or functions. Fine. So take an example of car. That is what is given here. Here also the last statement gives the example of car. Fine. The dashboard of the car. Okay, a car will have a dashboard. Fine. And in the dashboard you have speedometer, fuel gauges, and so many other things, right? Steering wheel, foot pedals. They are all called as the interfaces of the car, right? Interface of the car. If I consider car as an object, these are all the interfaces of car object. Fine. But the internal working is hidden inside. Okay, internal working is hidden inside. The process of hiding the members from outside the class is also called as encapsulation. Okay, implemented using the concept of access specifiers. I already told you, you have something called as private access specifier and public and protected. Private, when you make any data or function as private, it is private to an object. Okay, private to a class. But when you make it public, yes, it's accessible everywhere. Okay, so you can have the state as private and you can have the behavior as public, or anything could be done. But when the data is private, of course, even the functions cannot, the outside functions cannot use that data. Fine. Behavior could be public. You can invoke the function of one object in another object. That could be done. So the third property of it is message passing. We are discussing all these concepts with the help of examples later on. Okay, I am just giving you the description or just to make you realize the things. Later on, let us move to some little bit programming concept to understand these things. Okay. So the next concept or the next property of object is called as message passing. Okay. See, when you have a single object created, there will not be any use of it. Okay, one object, a single object may not be very useful. Okay, so in any real world application you consider, an object is a component of a bigger application. Fine, it is a part of an application. You can create thousands of objects, only then you can build a real world application. Just if I create just person or a human being as an object, I cannot do anything, right? He should interact with something to have some application design. Okay, even if I am driving a car, I have a car object, I have a person object, at least minimum 2 objects I need to have, right? Minimum 2 objects. Only then that is one application. Fine. Similarly, if you consider any bank, okay, there will be a lot of objects, customer, bank, account, so many objects, right? So one object will not be of any use. Okay, and when there are more than one object, how are these objects communicate? Why do you require more than one object? Okay, so when I am driving a car, if car is object and myself as one object, then I have to use the brake, I have to use the accelerator, I have to use the door, so many other things I need to use. That is what the communication what I have with the car, right? Maybe using the gearbox, I apply the gear. By using the pedals, I do so many other things, right? So there should be some communication between the objects for the application to work. Okay. So this object interacts with another object by invoking the the methods of that object. The communication happens by calling the functions or calling the methods or invoking the methods on other objects. Fine. So you have an example here. You can see a car by itself is not capable of any activity. A person interacts with car using steering wheel, gauges on dashboard and various pedals. Okay. And the interaction between object results in change of state. We have already discussed it, right? You apply or you invoke some functions for the data to change its state. Only when you press some key, the key is generated, right? In your keyboard, pressing the key is an action, is a method which changes the state of that particular key. All right. you can see an example here, okay, or the block diagram here, how the message passing happens in a procedural language like C and in a object-oriented programming like C++ or Java. Okay, in C, what we do, we write a function, it makes a call to another function, and it makes a call to another function, and so on. It is just you are calling the functions, and it happens sequentially, right? One function will have some local data within it. It can call another function. Again, every function will have some local data within it, and they return the values, right? In object-oriented programming, you can have multiple objects inside a program, and each object will have the data and its corresponding methods. Yeah, data surrounded by the methods. And the methods are basically, the default type of these methods are public, and the default type of the data are private. Okay, so these methods could be invoked. Object 1 can invoke the methods of object 2. It can invoke the methods of object 3, and so on. Okay, so any object can invoke the method of any other object. Right? This is how the message passing happens between the objects in case of object-oriented language. Now, we know what you mean by a method, what are its properties, and so on. Right? Now, what do you mean by a class? What do you mean by a class? You have integer data type, you have character data type, you have structures, which is a derived data type, you have arrays, right? All these things you have already studied in C. Similar to these primitive data types, okay, a class, it's a representation of an abstract data type. Okay, it can be used, this class can be used like any other primitive data type, like int, float, anything it could be. Similar to those primitive data types, you can use class. Okay. Generally, when you are writing such very simple programs, just to understand any other programming language, just the primitive data types or simple data types are enough. But when you are designing a real life application or real life model, then these primitive data types are not enough. Okay, primitive data types are not enough. You should go with some advanced concepts. That is why the usage of class is introduced. Okay. Uh, is there an example here? Okay, let me just give you an example. Fine. I have a bank application where I have to store the customer address. Okay, I have to store the customer address. Of course, the simple primitive data types are not enough because I should store customer's name, his account number, his address, and so many other things. Just the primitive data type of any programming language is not enough to store the customer's address, right? They will have the customer's details, I can say, right? Similarly, if I consider another example of, say, a date, okay, date. I cannot store the entire date in an integer data type, right? Because there will be 3 fields, month or day, month, and year. Some primitive data types are not enough to store date, right? That is where the application of some complex data types are introduced. Okay. Now, coming to this class. Class enables the programmers to create complex data structures, and basically they are to be modeled after real life data. Okay, our real world applications are modeled using the real life data, and in order to represent these data we need something called as class. Okay, the data structure is nothing but creation or how these data is represented in the system memory. Okay, so this class helps the programmer to create the data structures for modeling the real life data. Okay, so and this class, when I say a class, it has data, it has functions. Okay, so the binding of this data and functions happens inside a class. Fine. So you have data which are called as member variables, and you have functions which are called as member functions. Fine. Every class will have these two parts. First one is variables, member variables, and other one is member functions. Fine. So member variables will have all the members or all the variables required by the class. Okay. And in order to modify the state of these variables, what functions are required are written in the member functions section. Okay, there will be two sections: member variables, member functions. So look at an example here. Fine, objects and classes. You have a class which has class student, their name, registration number. These are the mandatory data or the variables a class will have. Okay. And in order to modify or in order to have some change of state with respect to these data or these variables, set name, which is a function which is used to assign the name to this name variable. Similarly, set registration number, and there is one more function to calculate the marks. And these functions, if you see, they are being invoked on these data you mentioned in the class. Okay, they change the behavior of the data or the variables you mentioned. So every class will have two parts. First part is the variable, second part is a function. Okay. These methods of the class operate upon the member variables of the class. Fine. Set name, set registration number, calculate marks are the methods of the class, and they operate on these member variables like name, registration number, and so on. Okay. This entire thing forms one class named student. Okay. Now, when you have the variables in the class, okay, variables or member variables, how do you mention it? Okay, what are the possible access specifiers? So the access specifiers are nothing but to decide what access is permitted on that particular member. Okay, member in the sense a variable. I have given name as one of the variable. Okay, character array name. Fine, that is my variable which I have declared inside a class. Now, who and all are permitted to access that data? That is decided by the access specifier you mention for a member. Okay. It could be private, it could be public, it could be protected. There are three possible access specifiers to decide the accessibility of the data and the methods you write inside the class. Okay. When you make the access specifier as private for any member, it could be a member variable or it could be a member function. For any member, when the access specifier is private, it is not accessible by any other object. Okay, private members, either a private member variable or a private member function, it can be accessed only by the methods in the same class. Okay, in the previous example, see, if I have this name as private, then this name can be accessed only by these three functions: set name, set registration number, and calculate marks. It cannot be used in any other function of any other object. It is private. Okay. Next, if you make the access specifier as public, that particular member is accessible everywhere. Okay, it can be accessible by the other objects or inside the object. Fine. In the entire program, even if you have 100 objects, that particular member is accessible by those or accessible to those 100 objects. Okay, it is like that. And protected is something which changes based on the scenario, based on the situation. And about this protected, we will be discussing more in the later coming classes. Okay, but of course, in the normal conditions, it is similar to private. Okay, you have a class. You have an example here. You can see. Okay, there is a scenario where there is a bank. Okay, global commerce bank. And this bank provides loan to all its customers. Okay, it provides loan wherever or whenever required to its customers. And when this loan is provided to the customer, bank wants to keep track of the loan taken by each customer and the EMI to be paid on monthly basis. This is a case study. Okay, understand it properly. The details to be tracked include customer ID, loan amount, interest rate, and duration. And EMI has to be calculated based on this loan amount, interest rate, and duration. Fine. This is one scenario given to you. And when I have a class, okay, as I said, class will have two things. One is the member variable and other one is a member function. And as per the scenario or as per the case study, the information to be stored are customer ID, loan amount, interest rate, and duration, right? In the previous one, it is given here clearly. The details to be tracked include customer ID, loan amount, interest rate, and duration. These four form the member variables, attributes, right? Now, in order to calculate the EMI, you need the loan amount, interest rate, and duration. So finally, you need to invoke this calculate EMI function, which is the last function given in the methods list. Fine. This calculate EMI function will calculate the total EMI to be paid by the customer, and this is calculated considering the loan amount, interest rate, and duration. Okay. The other functions you have is just to set and get. Set is you set the value. It's a kind of initializations you do to the variables, and get is to get the values. Okay, to print the values. It's a kind of like that. Set is initialization. Get is printing. Okay, and finally, with all these initializations and you get the values, you calculate the EMI. So calculate EMI function is invoked on the loan amount, interest rate, and duration variables. Fine. This is an example on this particular diagram is called as a class diagram. Okay. You will have one class. The first section of the class is the member variables and their return types. And the next section of this class diagram is called the member functions, which will have the functions required to be invoked and their return types. Okay, this forms the class diagram, and the first section, first row, you can see it is the name of the class. Customer loan is the name of the class, which has 4 member variables and 9 member functions. Okay, when this requirement is given for any developer, he will implement this class and he will provide all the functions. Okay, set customer ID, what it should do, what its return type, every function is implemented by the developer. Fine. This is a general class diagram. Any object oriented programming language can be used to implement this class diagram. Any doubts so far?
No, ma'am.
Okay. Okay. So you can see the same class diagram, its implementation here. Okay. But yes, this implementation is done using Java. Java is also an object-oriented programming language. And the implementation of that class which is given in the class diagram is in Java is shown here. Okay. Class is a keyword, okay, followed by the name of the class. And there are 4 data members are called as attributes. Okay, 4 data members, and all those 4 data members are made private. Okay, they are made private in the sense they are accessible only by the functions you define inside the class. It is not accessible anywhere outside. Okay, only these 9 functions which you have listed in the member function section can use these variables. Okay, and you can see the methods. Every method can use one of these variables, or any other variables can be used again. Okay, to calculate something. You can see the first set functions are all for designing the values or initializing the values, and get these to display or to return the values. Okay. Finally, calculate EMI will calculate the EMI of that particular person. Okay, by looking at the loan amount, duration, and interest rate. So loan amount into interest rate into duration by 100, you add it to loan amount to get the EMI. Okay, that is how the EMI is calculated. And this is the implementation of one complete class. Okay, you have a class name, you have the attributes which are nothing but member variables, and you have the functions which are called as member functions. Any doubt till here?
No, ma'am.
Okay. This I will continue in the next class. Okay, I will stop the class here because it's too much to remember. I don't know if you have worked on Java or C++, you understand it easily. But since majority of you are from a different background, I do not know how many of you have worked. I do not know. That is why I will not explain too much in one class. Any doubts you can ask me now.